Live now. We are together.
Yes, fab.
So the first thing, let me even cancel this one so that I show you. I have installed WEKA. So the first thing, I go to my start button and search for WEKA. I start this. So at start, this is what you get. Uh, so you remember that the data set that you sent me, it's the one that you are going to
Yes.
it's the one that you are going to load it here. You sent me two data sets. There was one in SPSS and there was another one in .ALR. We are not going to use that one in SPSS because the ALR is the one that is good and can be loaded in WEKA.
Okay.
So let's start. To import that data, you click this export and another window pops up. Now to load the data, you'll see all these tabs. There is process, classify, cluster, associate, select, visualize, all through those ones. Now we want to load the data. We click this open file and try to browse where the data is. Mine is in the downloads and it is this one. So you click it, then you open it. So before even we try to see this data, I think you have opened it. Have you tried to open this data and visualize it?
Yeah, I don't know what I'm
So,
doing, to be honest.
okay. So you'll find this variable called voter is just a index 1, 2, 3, 4, 5, 6, 7, 8, right? And we actually this one is not needed in the analysis. So we check it and then we remove it from the analysis. So we are only left with 9 variables, whereby the undecided variable, this one, is our dependent variable. So when we go back to our questions, the questions that we have here, let me minimize. I can maximize these. Okay, the first question: select select a suitable decision tree building in which pruning is embedded, building a classification model to identify the individual undecided. So the first question A is, in terms of the decision tree classification, what are the 4 variables that are important for this data set? Then we need to also answer the question, which features do not contribute or contribute extremely little to the decision tree classifier. So this thing briefly explain how feature ranking and selection works. As I remembering that the document that I sent you, I told you that you needed to research on this. So let's try to answer this question. What are the 4 important features of the dataset? Now, remember here we have been given a hint. You may use information gain or gain ratio metrics calculated by machine learning software to rank the features. In this scenario, I decided to use the information gain. So to use the information gain, we go back to our WEKA. Let me maximize. Then we go to select variable, this tab, right?
Yeah.
So when we click this, there is attribute evaluation. We need to choose the method that we want to use. So we click choose and we use information gain attribute. We click this. Now, a pop-up will come. You need to use ranker search method in order to use WEKA attribute selection gain. So should I select yes? So you should select yes, and that is why I told you you needed to explain how ranker, you needed to research on how rank features works. You remember that?
Okay.
So after selecting, actually when you click here, there are some informations here, but I would prefer we work with the defaults, so we don't change anything. So we just click OK. So uh, I chose in attribute selection, I chose the cross validation with the default features, the tenfold and seed is equals to 1. So to learn the features selection, we just click start. Pardon, 1 minute. Okay, let me delete this and explain again. Uh, Instead of going with cross validation, let's use full training set.
Okay.
Then we start it. We just click start. So this is the information, learning information that we get. We get that there are 5,000 instances. The observation are 5,000. We have 9 variables and evaluation on all training data. We have took all the data and we submitted to the evaluation. Now, look, here is the key information, this one. So the question here says, what are 4 important features for this data set? This is the rank, you can see, and they are ranked in descending order. The top one is the one with the highest rank. For instance, education is ranked the first one. So it's the first variable that influences the undecided. The second one is church. The other one is income. The other one is female. So to answer the question, which are the top 4, we take this. Are we together up to that point?
Yep. Yeah.
Now, the other question is, which features do not contribute or contribute extremely little to the decision of tree classification. Now, look at this. When you look at age, it is ranked as the least with a rank of 0, right?
Mm.
The other one is married. It is ranked as the second least with a rank of this, right? The other one is household size with this rank. So we can say these three features contribute little or no to the decision of the tree. Are we together?
Yes. Yes.
So, so this question is answered, right? So what you are only left with is to research on how to explain how features ranking and selection process works with support of reference. Is that okay?
Yeah. That's fine. Thank you.
So let's go to the second question. The second question. A minute. I read a message here. The second question says, remember this. Select a suitable decision tree in which pruning is enabled. Keep
Mm.
that in mind. Are we together?
Yeah.
So select the whole data. Select the whole data as the training and present and briefly explaining the resulting decision tree. Model including the selected variable and the number of voters for each class at different node. How many parents node and how many children's node. So in WEKA, one of the one decision tree in which pruning is is embedded, it is called J48. Are we together?
Yeah.
So to do that, we go to this task classify. Then we choose the model. The model, we click here. The model is a decision tree. So we click this tree and we click this J48. Are we together?
Yes.
So there are some features you can tune the parameters of this model, but because we are not told to tune, we can just use the default. So, but there is one thing that I would want you to note. You can see when the mouse is.
Yeah.
So it says whether the pruning is performed. So if unpruned is false, the pruning is done. If we turn this to be true, the pruning is not done. So we leave it as false so that we allow pruning. Are we together?
Yeah.
So we click OK. So the question says select the whole data as training. So we go back to WEKA. So instead of cross validation or supplied this, we just use training set. Are we together?
Yeah.
So we select the whole data as the training set. So you can see where my mouse is.
Yeah.
This is where you select the dependent variable. You can select all along, but we know our dependent variable is undecided, so we select the one. Are we together?
Yes.
So to start this model, you click start, and the result will come. So allow me to minimize this so that we can see the question what they are requiring us to do. So yes, we have trained the model. We have trained the model. So we ask this, briefly explaining the results. Briefly explain the result. What is more important is this. Correctly classified instance. Are we together?
Yeah.
So we can see our model performed with 98.5 to accuracy, right?
Yeah. Yeah.
So,
Higher. Yeah.
okay. Uh, Briefly explain the resulting decision tree model, including the selected feature and the number of filters at each of the nodes. At each of the nodes, okay, that one we shall go. So we are together. Our
Yeah.
model worked with 98%. So to calculate this, we know the total observation. The total observation were this one, 5,000, right?
Yeah.
The accuracy is defined as the proportion of collected predicted over the total number. So we can see if you take 2906 plus 2020, then divide by this times 100, you are supposed to get this.
Yeah.
So that we get the accuracy, right?
Yeah.
So let's go back to the question. A model including the selected attributes are the number of voters at each class at different nodes. So we are going there. We are going there. So that we can be able to visualize this, so that we can be able to visualize our decision tree, we remember it is this one.
Hmm.
We right click, then click visualize tree. Are we together?
Yeah.
Now another our tree is actually formed. Maybe you can see it well.
Yeah.
So so uh, let me first of all answer this. How many parent decisions and how many children nodes are included in the model? So a parent decision is any decision that is in a, I will call them I will call them this is oval. I'll call them all ovals with branches.
Okay.
Those are parent. Anything that does not have a branch is a leaf or a child. Are we together?
Yeah.
So how many parents do we have? We have this parent. That is, we have this parent. You can see where the mouse is.
Yeah.
We have how many parents? One, two, three, 4, 5, 6, 7, 8, 9, 10. Are we together?
Yeah.
We have 10 parents. How many children of leaf or leaf? Anything that does not branch is a leaf. Are we together?
Yeah.
We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Are we together?
Yes.
So those are the numbers of leaves that we have. So, okay, is there another the number of voters for each class at different node? Look, number of voters at each class uh, uh, in each and every node. Are we together?
Um.
Look at this. Can you see this clearly?
Yeah. With the.
Uh,
See. Yeah.
Try to read so that I see whether you are seeing it clearly.
0 and then in the brackets 1338.0 slash 33.0.
So this is the way.
Okay. I did it. What does it mean?
This is what it means. Zero,
Yeah.
zero, zero here it is for decided. One here is for undecided. Are we together?
Yeah.
So we have 138 decided voters and that really undecided at this node.
Okay.
Should I repeat?
Yes, please. Sorry.
So we start 0, 1, 0, 1, 0, 1, right?
Yeah.
The first the first thing here it is indicated as zero. Excuse me. The
It's
first
okay.
the first the number here is indicated as zero. So the first number indicates this corresponds to zero.
Right. The
So
decided voters.
so we have 1338 decided voters
Okay.
and 33 undecided voters. Are we together?
So there's 1,338 decided voters.
Yeah. Whose education was more was less than or equals to 12.
Oh, okay.
Can you see the conversation over there?
Uh, where?
Look, this branch says is education less than or equals to 12.
Yeah.
So we have We have 13, that 8 decided voters,
8?
and that 3 undecided voters.
Is that 1,338 decided voters?
Yeah,
And then what is the 33?
the undecided.
Oh, okay.
Are we together?
Yeah, that makes sense. And then 33 are undecided.
So you go down with the conversation.
Okay.
Education is greater than 12,
Mm.
but the church, what is the church? One is goes to church, but they do not go to church,
Yeah.
and they are male
Yeah.
with their educations less than 17,
Yeah.
and their income is less than 174.
Default income. Yeah.
So we have 128 of them being undecided voters. Note here there is no slash.
Yeah.
So we do not have the decided voter.
Okay.
Now we go back again. Education is greater than 12.
Yeah.
They don't go to church.
Yeah.
They are not female.
Yeah.
Their education is less than 17,
Yeah.
but their income is greater than 174.
Yeah.
We have that 3 undecided voters
Yeah.
and 1 decided voter.
Oh, okay. That makes sense now. Thank you.
Look at this. Education is greater than 12.
Yeah.
Okay. They don't go to church,
Yeah.
but they are female
Yeah.
with income greater than 174,
Yeah.
but their education is greater than 17.
Yeah.
But to be specific, their income is also greater than 251.
Yeah.
We have 24 of them being decided voters.
Ah, okay. Is that how I would describe the tree then?
That is how you describe the tree.
Do I need to do that for all of them?
We are
Do you
trying
think?
to do that to all of them.
Ah, just right. That makes more sense.
Right. Are we together?
Yeah.
So the question one, when you decide to do that, you shall have completed this question one.
Ah, okay.
Should we go to question two?
Yeah. That makes sense.
Okay. So let's click this. So the question two says, you can see the small the small screen.
Yeah.
Consider the scenario where the given data is split into training and validation test using the K-fold cross-validation approach. Pruning is also embedded. So still at this point, we are going to use J48, right?
Okay.
So question one, use tenfold cross-validation method. Discuss the performance of the pruning, including the accuracy, showing and show the interpretation of the classification stroke confusion matrix, present the ROC class of the class indicating undecided. You remember undecided here, it is 1. Are you together?
Okay. Yeah.
Using the key performance measure including overall, false negative ROC, explain any difference in the cross validation model to that test performed in the whole data set in 1B. So let's perform this cross validation. So still, remember, we are using still the J47, right?
Yeah.
But this time we are told to use the cross validation. So we click this cross validation. How many folds? 10. Are we together?
Yeah.
Then we don't change this because still our dependent variable is undecided. And here, when I say undecided, it is the column that is named undecided, right?
Yeah.
So we click start. So we see new now, new new classification results. Are we together?
Yeah.
So let's go to this. What is the accuracy rate? This is the accuracy rate. Okay. Add show and interpret the confusion matrix. So the confusion matrix here, it will mean, let me open a new Word document here. I show you, maybe Excel. Let me open this and show you. So the confusion matrix it will mean this. Let me show you. This will be actual and predicted. So we shall be having A, B, total, and we shall be having A, B, and total. And then here we shall be having the grad total. So this is taking long. Let it finish loading and then. They're not responding. What's up? Okay, it has responded. So look at this. This is the confusion matrix. Are we together?
Yeah.
So the confusion matrix we always display like this. A, and remember A is for 0, which in our question here, 0 is decided, A1 is decided. So we should name A equals undecided. Is it undecided or decided?
But
A is 0. 0 is, which is decided. A is decided.
is that how you meant to answer question 2?
Okay, B is undecided. So with that one we can remember. So we see A for A, we have 2904. So, and this one is 4. This one we can sum so that it is not included in this, but it's actually this what I'm doing here, and we can do this. So the other one is 73 2019. Are we together?
Yeah.
And this one is equals to this plus this one, and we can see our total here is actually our total observation, which is 5,000. Are we together?
Yeah.
So the question here says, what? The accuracy, we have seen it is 98.46. And so interpret the classification or confusion matrix. Look, to interpret this, to interpret this,
Mm.
to interpret this, we shall say this: out of 2908 decided, voters, 2904 of them were predicted to be undecided. To be A is for decided, sorry, to be decided. So out of this number, this one was predicted to be decided. Are we together?
Yeah.
Now, the other way around, now for B, you shall say out of 29 to undecided now voters 2023 2019 2019 sorry of them were correctly predicted because yes, B, we are correctly predicted this B. Are we together?
Yes.
So there we have actually described our confusion matrix.
Ah, that makes
Now,
sense.
you can also try to search online at how to interpret confusion matrix. And we shall see something called we shall see some people confusion matrix. Yes, for instance, when you try to use this block, use you shall see accuracy is true positive, true plus true negative, plus true positive plus this. I want to show you how you can name our true positive and our true negative. Let's use this. So we can see this here. This one
Mm.
is our,
Mm.
so this table here we can still copy. Let me paste this. This one, it is our true positive. This one, it is my false positive. This one is false negative, true negative. Are we together up to that point?
Yeah.
Now you can try to use this interpretation here, and we can try to use this and calculate what is our recap. It is our true positive divided, it is our true positive here, which is 2019, divided by true positive plus false negative. Are we together?
Yeah.
And then express it as in percentage. For instance, now here, our recall, it is our true positive, which is 2019, 2004, 2004 divided by our true positive, which is 2904 plus 73. Then you can try to express it as a percentage. So this is our recap. We are together.
Yeah.
So when you are told to calculate the precision, the precision, it is true positive plus true positive plus false true, it is true positive, all of a true positive plus false positive. Are we together?
Yeah.
So you can try to calculate, for instance, in this one, you try to calculate precision, and you shall see it is equals to 2904 divided by 2904 plus 4. Then you can express it as a percentage, right?
Mm.
And with these two, actually you have actually described our confusion matrix. Are we together up to that point?
Yeah. Yeah, that makes sense. Thank you.
So okay. So present now let's go back to our question. Present the ROC for this class. Okay, 1 minute. 1 minute. Just 1 minute.
Okay.
Okay, I'm back.
Okay. Thank you.
So here we are told present the ROC for the class value indicated and decided. Undecided here is undecided is 1. Undecided is 1. Okay.
Mm-hmm.
ROC. Now we go back to our model. It is this one, remember?
Yep.
Then right click. Now go to visualize threshold curve and select one. And this is our ROC. We are just told to present it, but we can comment what is our ROC. Are we together? Hello.
Yeah.
Then you can
Hi. Yes.
search online what is ROC. Are we together?
Yes. The 0.9794.
4. Then try what is our ROC. Because
Okay.
when trying to write a report, are we together?
Yeah. Yeah. I'll write the report on that. Thank you.
So okay. So explain any difference in the performance of the cross-validation model to that model that you performed in A. Are we together?
Yeah.
I would like you to note this. This is,
Yeah.
what is this? 98.46.
Okay.
Let's go to the model that we performed earlier. This one. 98.56. 52. Are we together?
Yeah.
So which one is performing best?
That one.
This one.
Yeah.
Yes, this one is the one that is performing best. So you to answer that one, we would say the model in question 1B, it is the one that is performing best because the accuracy is high than this one.
Okay.
Are we together?
Yes. Yes. That makes
Now we
sense.
can go to question 2B. Right?
Yeah.
So consider this. Let me open an Excel in another sheet. Let me open another sheet here. Consider this. 60. So age is equals to 60 Are we together?
Yeah.
Female is a man. So female is 0.
Okay.
Who attends to church? Church is equals to 1. Are we together?
Yeah.
Has 15 years of education. Are we together?
Yeah.
Owns a house. So owns a house. So owns a house. It is represented by owns a house. Home owner. Home owner. 1 for yes because he owns a house, right?
Yeah.
Is married. So married is equals to 1. Yes. Are we together?
Yeah.
Okay. Lives in a household with 4 people. So household size is 4. Household size is 4. Let me abbreviate with HS. It's 4. Are we together?
Yeah.
Has annual income of 18,180,000 income. Are we together?
Yeah.
Then we are told that's the pruning tree in part 2. In part, we are told does the pruning tree in part 2A classify these voters as decided? We should say yes or no.
Okay.
Are we together?
Yeah.
Now, to answer this question, I did this. To answer this question, I did this. I went back to where my data is. I told you it is in downloads, and downloads. It is this one, this data. I tried to open it.
Mm.
When I tried to open it, this is how the data is expressed. This is how the data is expressed. Uh-huh. All these things here, but what we should know, voter is numeric. It is this one. Age,
Mm.
this one. House owner, this one. Female, it is this one, and so on and so on, and decided the last one. Are we together?
Yeah.
So I decided this. Let me close this. I decided to have another data, but or should I? Let me show you what I did. I copied these. Copy.
Yeah.
Then I tried to add another one here. Add. Then I pasted. You remember when loading the data, I removed I removed voters, right?
Mm.
So this one, let me remove this one. This one. And when I remove the voter, I should also remove the first column here because it represents the voter. Are we together?
Yeah.
Each row represents an individual person. So because here we are told to predict only one person, we should have only one row. Are we together?
Yeah.
So let's try to fill this data. Let's try to fill all this. So 60 old man. Are we together? 60 old
Yeah.
man. So the first here, age, it is 51 here. So we should replace it with 60.
Yeah.
Uh, we should replace it with 60, right?
Yeah.
Old man. So old man, female. Female is 1. Man, it is 0. So 1, 2. So we should also, this one is for house owner. The next one is for female. I don't think are you following my way of
Yeah.
writing?
Yeah, I understand.
So has 15 years of education. Where is the education? Education is 2, 3, 4, 5, 6, 7. That is education. So
Mm.
we should try 1, 2, 3, 4, 5, 6, 7. How many years? 15.
15.
Owns a house. Homeowner? Yes. So this one should remain as 1. You are following?
Yeah.
Is married. So 1, 2, 3, 4. Married should be 1. 1,
Mm.
2, 3, 4. This one should remain as 1. Are we together?
Yeah.
Lives in household with 4 people. Household size. This one. This is 2, 3, 4, 5. So 1, 2, 3, 4, 5. Household should be with 4 people. So the 4 should remain.
Yeah.
So has an annual salary of 18,180,000. So remember, look at this. Income expressed in thousands. So this here it is 170,000. So
Yeah.
we should replace it with an 80,000. Am I communicating?
Yeah.
Okay. And that is the case. Are we together?
Yeah.
So we should not supply. We should not supply whether it is undecided because we are predicting. We should not. This one should remain. Sorry, but we should not supply this. Are we
Okay.
together?
Yeah.
Let's try to save this. And I'm going to save it as test 1. I had tried it. Let's save test 1, 1.arff. Let's save in that format so that it will be used by WEKA effectively. Are we together?
Yeah.
So, and we have saved it in our downloads. Let's save it. So let's try to predict. Let's go back to our WEKA and we try to predict. To predict, this is how to go. We are still using J47. Are we
Yeah.
together?
Yeah.
We need to click supply the test set.
Yeah.
So click set, then we browse. Wait, and we click this and open it, then close. Then we need to test. Are we together?
Yeah.
So let's start. So look, this is very interesting. This is very interesting. Total number of instances. This is very interesting. Why total number of instances should be? No, 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 no. It was not saved the correct way. Let's save. Let me delete that. Where instances are. Then I'm trying something here. Okay. Let me try using the data that we. Okay, we should do this. We should do this. Let's delete that. Now, this is the data that we are trying to do. This is the data that we are trying to predict. So we should have 1, 2, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6, 7, 8. Then let's put, because we want to, where is the question? We want to test whether it will be predicted as undecided, and undecided is 1. Are we together?
Yeah.
Let's put this as 1 and see whether it will be predicted as 1. Are we together up to that point?
Yeah.
Let's save. Let's save. I've saved that. Let me close. Now we click supply test data. Let's This is the data that we want to supply. Class yes, the class that we want to be is undecided. Then we click close. Then we start. You see how many observations,
Yeah.
the number of total number of instances that were predict. It is 1 because we supplied only one person. Are we together?
Yeah.
Now, this person, let's see where he was classified. Look, he was classified as 1. He was classified in column A. Are we together?
Yeah.
And A is for 0. And 0 here, it is decided. Are we together?
A is equal to 0.
Yeah. And 0 is
And,
decided.
and 0 is equal to decided. Yeah.
Decided. Are we together?
Yeah.
So the question here, is this voter predicted as decided? The answer is no.
No.
Should I repeat?
Best print.
Yes?
Best print tree in part 2A. Classify this voter as undecided. No, it's okay.
We are together.
Yeah.
So we should explain that the person was not predicted as decided
Okay. But he
because
was not
yes,
predicted
yeah,
to be decided.
yeah, it's not predicted as decided.
Undecided or decided?
He is not predicted as undecided.
Oh, he is not. He is not a undecided. Oh, okay. Yeah, that makes sense.
So we are together up to that point.
Yeah, you know, for question 2A,
Yeah.
the last bit says, is this model practical for identifying undecided voters?
Is this model practical for identifying undecided?
Undec-
Okay, let's go back to this
so,
for model 2. This
yeah,
one.
2A.
Okay. Okay. Is this model practical for identifying undecided? So,
Yeah.
okay, there is something that is called sensitivity.
Mm.
And sensitivity is actually what it's actually, I would say, is actually the way the word sensitivity means. Are you sensitive to heat? Yes or no? Which
Yeah.
percentage of sensitivity are you? Are we together?
Yeah.
So, okay. Uh-huh. Is it precision that is called one of look, sensitivity is also known
Okay.
as recall or true positive.
So that's from the confusion matrix.
Yeah, or TPR. Okay. So sensitivity is called a recall. Are we together?
Sensitivity is recall, yeah.
Sensitivity is recall. Sensitivity into bracket recall. Are we together?
Yeah.
So
Yes.
we want to answer whether our model is our model sensitive to is our model sensitive to undecided. Are we together?
Yes.
And our undecided is is one.
Yeah.
So let's see. Let me show you. Is our model sensitive to our one? Here is our recall. So this is our recall.
All right.
96.5. That one is pretty fine. So we would say our model, yes, it is sensitive to undecided. So it can be used to, so, question 2A. Can be used practically to identify undecided voters because we can see our recall is pretty high. Are we together?
Yes. Yes. That's good.
So 2A done, 2B also done, right?
Yeah. Thank you.
Yeah, let's go to question 3. Question 3. Okay. Question 3 says learn logistic and also neural network with the tenfold validation. Are we together?
Yes.
So the first thing we shall learn is logistic with the tenfold validation. So we click cross validation. Are you together?
Yes.
So at the class file, we click choose. So the logistic is under the functions. So we click here the function, this one, and we take we choose the logistic.
Yeah.
And you can see here the logistic is selected. So there are some parameters here, but we choose to use the default. Are we together?
Yeah.
Then learn. We click start. Look, we are told here
Yeah.
what is the accuracy. Here is the accuracy. Uh, if you read through
75.
75, this is very bad. This is a bit bad, Silio,
Accuracy. Okay.
right? So, okay, we are told ROC value, show and interpret. Oh, this is our confusion matrix. Are we together?
Yeah.
Based on this and the confusion matrix that we had described there before. See, you can try to argue about.
Classification.
Yes,
Yes.
because I will also share with you this video. You can also keep reviewing. So this confusion matrix, you do the way we did it there before.
Okay.
You remember this confusion matrix. This one here. You do
Yeah.
the same way.
Okay.
So what is our ROC?
Thank you.
So to get our ROC, we go to the model, right click. This one visualize the curve. Then this one, this is our ROC. You can see our ROC 79,
Yeah.
and that's why you see this curve 79. Remember that the other one was about 90 something, and the curve was almost here. So this is
Okay.
our ROC. Are we together?
Um. Yeah.
Okay. Then for the logistic model, what cutoff would lead to the highest possible value of accuracy? So look at this TSP rate. When our cutoff is about 8.831,
Um. Where are we now? Sorry.
no, this in question 3A.
Okay.
For the logistic regression model, what cutoff would lead to the highest possible accuracy rate?
Okay.
So there is something that we are going to research while writing, explaining how the optimal cutoff value is selected for logistic. You can search that online, how this is selected for logistic model. Is that one okay?
Uh. Yeah. Yeah. I think so. Where was you? But just probably a high value, isn't it?
Yeah.
I'm not very good at this. Okay. How do I just find that through books? Is it?
Yes.
Yeah.
Pardon?
Just get a book to support. Do I just look through like textbooks to support that?
I can't hear you.
For that part,
Yeah.
uh, where it says what cutoff value would lead to the highest possible overall accuracy rate.
Yeah.
Do I just find that in textbooks
Yeah. You can search that in textbooks.
and just reference it, isn't it?
Yeah, and reference it.
Okay, that's fine. Thank you.
So, so that one is for logistic. The other model that we need to show is neural network. Are we together?
Okay. Yes.
So neural network in WEKA, we just go to classify, choose, then go to the function. these functions, then go to multi-layer perception. This is the neural network. Are we together?
Choose function.
Choose multi-layer perception.
Okay.
So you are still using cross-validation with the 10 folds, then we need to start it. Are we together?
Yeah.
Uh-huh. Uh-huh. And here is the summary. So this is the accuracy.
Yeah.
Our confusion matrix, you can try to argue about the way we did to this one.
Yeah.
Okay, we need to show the ROC. ROC, then you click this, right click, visualize threshold for this for one, and you can see the ROC is 98.2%. Are we together?
0.92. Yeah. That's a high one.
Are we together?
Yeah.
Okay. Now, so after explaining those, the logistic and the neural network, we shall have done the DLA. So the DLB asks us which machine learning method, either decision tree, logistic, neural network, do you recommend for using to identify undecided voter? Justify your answer by providing side-by-side performance. Now, look, side-by-side performance. We shall do this together and see. Okay, model, ML. We have a decision tree, logistic, neural network, accuracy. So, multi-layer perception, this one, neural network here, it is 97.72. Okay, logistic here 75.7.4. Decision tree we used it here.
Mm.
This one 98.46. And this decision tree, which is neural net decision tree. Look, if we try to plot this,
Do I need to do ML?
yes, ML is for machine learning.
Oh, right. Makes sense.
Machine learning model.
Uh,
And we try to, we can also show data. Let's try to see this. Now, tell us, which one is performing best?
the decision tree.
Yes, and that is the answer to that question.
Is that it?
That is the answer to that question.
Oh, okay.
So So justify your answer. Why would you recommend this? I would recommend this because it has the highest accuracy level. That is the justification that I would give. And then produce this graph. And we are done with our questions.
Ah, fab.
Yes?
Okay. No, that's good. Do I need to compare like the confusion matrix for
No,
each of them?
you don't have to, because accuracy is calculated from the confusion matrix.
All right.
You don't have to show.
That's true. Oh, fab. Makes life much easier. Yeah. I think that's everything then. Um,
So that is what I did for that.
that's great. How long did it take you to do it?
Yes?
Did it take you long? Did it take you long to do it, or did you find it quite easy?
I've got some experience in this. So let me stop the recording so that